Hello? Okay, yeah. So a lot of people turn up, so I think my catchy title worked out. Right. You can see the theme is inspired from the movie Seven. Who's seen the movie Seven? Raise your hand. Great. Because I spent like probably 3 hours working on that image. So if nothing, at least you can give me credit for the Photoshop. Okay? If you don't like my tips. My name is Weir. As of 8 days ago, I worked for Oracle in the hospitality business unit. You might not know, but Oracle does software for hospitality. Before that, I was in Capgemini. I was a chief architect, and I had the pleasure to help very big organizations drive their API strategies. And a lot of that experience I'm actually sharing in my coming book titled Enterprise API Management. It's going to be released next month. It's literally over writing. So everything you're seeing here is going to be kind of articulated in a more detailed way in my book. So that's me. You can follow me on Twitter if you want the slides, or I'm always tweeting stuff about APIs, so if you're into it, yeah. Needless to say, these opinions are my own, and it's going to be opinionative. You might not agree with what I'm going to say, but if you can learn something from it, I'm going to be a happy man. I think that's the key of this session. APIs are doors to functionality and information. Everyone knows this, right? But what happens when you get that design wrong? I mean, the doors can be completely useless. And raise your hand if you have ever made mistakes writing software. Who doesn't, right? And that's the key here, right? The key is to learn from those mistakes, but also understand and learn from others as to how to fix those issues, right? And I'm using the 7 deadly sins, right, as a way to articulate that. By the way, the inspiration of this presentation came partly from Daniel Bryant. I don't know if you know him. He's a Java champion. He did a very good presentation titled The 7 Deadly Sins of Microservices. Check it out as well. It's really, really good. Obviously, my focus is on API design and how to avoid common pitfalls to not commit, or should I say, not git commit any of the deadly sins. Yep. Right, so let's crack on. The deadly sins are pretty much in Christian tradition, sort of like perversions of, it's like, I just read it actually. Perverse or corrupt versions of love, right? That's what kind of it means, right? So I just go for the first one, which is lust. It's kind of like unrestrained desire for something, right? Like try this tool, try that tool. So many tools out there these days, right? So much technology, and we want to try it all, don't we? Because it's cool, it's interesting. But the issue here is you can end up with a perfectly useless API. It's beautiful, right? You spend so much using the right tools. You're using the latest and greatest version of Istio, running on the latest and greatest versions of Kubernetes. Your pipeline is brilliant. You have, the best Git flow or whichever Git flow you like. But then when someone, the consumer, is going to try that API, it's just like, it's impossible. And I've seen this in the past, and that's not good. And the motivations for this sometimes is, it's lost, right? We are carried away by the tooling aspect of it. We can be a bit selfish and say, oh, let's try the tool, and we kind of forget a little bit that the usability of the API is, as, if not sometimes more important than the way you write it itself. And that's kind of, the way to prevent that. There is a technique called API Design First. Raise your hand if you've applied this technique before. API Design First. Well, not a lot of people, so I'm glad I'm sharing this tip, right? There are tools out there like, well, I'm a bit biased towards Oracle because I work for Oracle, but there are tools out there like APIary or Swagger Hop, which kind of open, that helps you work exclusively on the design first lifecycle. What it means is that you spend a fair amount of time working on your Swagger definition, for example, or your API blueprint definition. And this type of tools kind of generate, they have mocking servers, so you can kind of mock design, so you can then share, right, the designs that you're producing, so your consumers or your developers can try out the API before it's even built. You haven't write a single line of code all you're doing is prototyping, designing, mocking your API on the fly. If I have time, I can do a very quick demo of how this works. But the idea being is that you can establish feedback loops very early on the life cycle, right? So by getting that feedback, later on, you don't have to rework your API. But most importantly, you ensure that your API is fit for purpose. Because that's what really matters, right? That your users can actually use it. And the experience of using that API, it's a good experience. In fact, there are conferences focused exclusively on the topic of experience. There's one called API the Docs. It's really, really good. If you're into experience, I recommend that conference. So that's the first one. The second one, this is probably one of my favorite sins, gluttony, which is, well, overeating. I'm guilty of that sin, by the way. I love eating. Not that burger, no? That's not me. So the issue here, I call it the API sandwich architecture. We're moving into the cloud. And then you can have so many layers, right? Then you have your edge proxy, then you have a load balancer, then you have a backend for front end, then you have another load balancer, then you have an ingress gateway, then you have another load balancer, then you hit the micro gateway, because actually if you see like analysts' recommendations, they do recommend like 2 or 3 layers of gateways. I'm like, huh? So you end up with a very complicated stack, which obviously is going to be more difficult to maintain. It's going to be, you have more, points of failures, and troubleshooting won't be easy. Needless to say, layers, unless they are really, really justified, they can really cause problems, right? So how to avoid this type of stuff, right? Well, at least this is my opinion. You don't need many gateways. You need one gateway. Why? Because the gateway is going to be where you're going to enforce your policies. That's really one of the main reasons of gateways. And there are many gateways out there. I like the gateways that run natively in Kubernetes. Some people refer to them as micro gateways. Another name is ingress gateways, like Istio has an ingress gateway, for example, but Kong is a good alternative, or Ambassador is another alternative. Oracle has one that's going to be released very soon as well. The bottom line is, right, think about your stack, adopt the layers that really add value. Yes, you're going to leverage your cloud infrastructure. You're going to have a traffic management service, because if you have an API that's globally deployed, you want to make sure that if I'm calling the API from Australia, I'm not hitting the gateway that's actually in North America, right? So you can use a DNS service to help you resolve to the right region. Cool. That layer, that technology is justified. Maybe you want a web application firewall because you want to prevent against common failures, like, for example, those explaining the OWASP top 10 project. Great. You can, it's justified. Maybe if you have 2 Kubernetes clusters in 2 availability zones, maybe you want to have a load balancer. Okay, I can understand that. Yeah, someone is calling me. Let me just hang this up. So the idea being is, this stack is quite common these days. I've seen it in many presentations during the conference. It works. I've had the opportunity to implement this in production, and it's an efficient architecture. Obviously, I'm simplifying it. But you don't really need that many gateways, and that's kind of my first, second recommendation on how to avoid this sin. The third one, greed. Well, you want something so badly, right, that you just go for it. And again, this is a very, very common thing, and I see it a lot. And it tends to end up in a very religious debate. And the reason being, I call it the chatty API. Raise your hand if you know what hate OAS is, or you're implementing hate OAS in your APIs. Hypermedia as the engine of state. It's kind of a technique, or actually it's a constraint within the REST architectural style that indicates that you should be hypermedia driven. It's kind of like the web when you navigate through links, right? And you don't have all the information in a single page. You have a page. You provide summaries, and then you start navigating through your links, right? Hypermedia APIs are kind of like that. So you don't present the entire payload, when you do a search, for example. Your return collection is going to be a subset of the resources that you found on the search. And then there is literally a link, a URI, that takes you to the detail of a particular item within the collection. Nothing wrong with that. In fact, I think it's a good practice. But when you overdo it, when you overdo hate OAS, right, then you go to the sub-resource, and then the sub-resource have 6 more sub-resources, and then you have 6 more. So you can end up in a very chatty conversation. And that's not good. Because you might think from the server side, my design is elegant. From the UI side, they are having to make all these calls. And another motivation for this, and it's one I hate, is batch downloads. So you want to download 1 gigabyte of data. And I've seen this, there was a requirement from the government in Sweden to implement a large pagination to download literally gigabytes of data. And I'm like, what? So what happens is, you want to iterate through the API. So give me the first 1,000 records, then give me 1,001 to 2,000, 1,000, and so on and so forth, right? And then you end up having to loop so many times to download the data. Well, maybe that's not the right pattern for downloading a lot of data, right? Maybe you should think about other options, right? And that's kind of what my recommendation is, right? So there are different ways to address this problem. The hit OAS, which is the bottom one, could be prevented by API composition. Who has read the website called microservices.io? Come on, don't be shy. I'm sure most of you. Well, if not, check it out. There's some very good patterns there by a guy called Richardson, who just published a book called Microservice Design Patterns. And in there's a very good definition of the API composition pattern. I think this pattern is quite elegant, especially if you implement it with a technology called GraphQL. I'll talk about it in a second. The idea being is that you prevent the UI from having to do that composition and making all those calls, right? The server will do it for you in a very good way, and I will talk about that in more detail, as I said. Another option, right, to prevent, like constantly pulling an API, if that's what your consumer is trying to do, you can implement web events or webhooks. The idea being is that who comes from the WSDL SOAP world? Raise your hand. Okay, I know your age. It's probably about mine. Yeah, it's all stuff for the guys that do Node.js and JavaScript. Anyways, it's kind of like WS addressing in the old WSDL SOAP world. Is a callback. It's an asynchronous callback. What you're doing basically is you are subscribing to an event. You're saying, look, I want to subscribe to customer, whenever the customer data changes, notify me of that change. I don't want to come and constantly pull. Just call me back, and that's what a webhook is, right? Of course, there are techniques to implement that. Typically, you need to implement some sort of event hop on the underlying infrastructure, right? So you can listen to those events, and then you can send them back, right, as part of your asynchronous callback. The implication as well is that your consumer needs to be able to receive that callback, right? So the consumer will need to have some sort of endpoint to listen to you, or sometimes there's something called WebSocket, right? It's another technique that you could apply if it is kind of like a JavaScript or mobile device. So that's the grid. I'll go to the next one. Laziness. What better example than Homer Simpson? I like him, though. He's funny. I call it the rip fool. There's so much documentation out there about REST. Literally. I mean, there's no need to kind of, read books or just Google REST design best practices, and you'll find tons of information about it, There's no excuse, in my humble opinion, for a bad REST design. Although sometimes it's motivated from a common issue I see is you want to automate the conversion of an old service built in a different paradigm, like a WSDL, right? WSDL follows the RPC, it's an RPC API style, right? A remote method, a remote procedure call. But the paradigms are different, right? In RPC-based APIs, your intent is expressed in an operation. Get customer by name, get customer by date, and then you have a bunch of operations describing what the intent is. In REST, the way you model your resources is different, right? You use the HTTP verbs. Your resources are elegant, typically starting with a plural, like, for example, customers, / your customer ID, then / sub-resources, and so on, right? That's a very common practice, right? But then, when you convert from WSDL, you might end up with something like that. Update orders, horrible, right? And then I come back and say, so fine, you're converting from SOAP to REST because you want to use JSON, but then you're not really improving your design, then what's the point? You change the technology, but you haven't really introduced any enhancements, any improvements to your design experience, right? So for me, that's not a good practice. And that's kind of where I'm coming from here, right? Another common mistake is, when you do a search, there's no constraints, right? So you get, a response can be unbounded. Like, you're doing a select star from a database, and then you get, like, boom, a whole bunch of a massive collection. And then you get 3 code like that, and then all of a sudden you bring down your server and your database because you didn't put a limit. So I see that. I've seen it a few times, I have to admit, right? So there's no limits, and that's a very common mistake as well. Yeah, and it continues. What I was talking about, hate OAS, right? It's not rocket science. As I said, if you have a sub-resource and you don't want to provide all the information of that sub-resource, like the customer details, right? Don't just put an ID or something that doesn't mean anything. Provide a URL, let people then access that resource by providing that information so it's easier to consume that API. By the way, but don't overdo hate OAS because you will end up with the chattiness that I was talking about before. So to prevent these issues, I think there are some very common good practices that you can apply. Like, for example, use HTTP verbs to define your core resources, like orders, and be consistent on that. Always implement limits and offsets. As a good practice, don't allow APIs to be implemented without this because you can end up with the issue I mentioned before, especially if you have lots of records in that database. And the other one is HTTP status codes. What error code should you get back when you do a post? Anyone? I heard the answer somewhere. Who thinks it's 200? Who thinks it's 201? Good. I'm glad. All right. So you know more than you're pretending because you didn't raise the hand earlier in a simpler question. So that's good. Yeah. Sorry. There's something called the Richardson maturity model, which explains hate OAS, right? But please, as I said before, don't overdo it. And the last one is high potency. Who's heard of that concept before? Good. I'm not going to spend time on it. Everyone knows about it. So I'll move on, right? So wrath. I always struggle to pronounce this word. I don't know why. Wrath. So it's like an angry developer. You're like pissed off because for a reason, like for example, there's no API documentation. So you need to consume an API, and then you try to read that thing, and you're like scratching your head and really like cursing. I was blessing cursing, right? It's like, how am I supposed to consume this thing? The documentation is either rubbish or there's no. Maybe you got a Java doc or something like that. It's like, come on. Proper documentation is extremely critical, especially in REST APIs, right? I hate accidental APIs as well. It was kind of like a prototype, then it was released, and then people are using it, but there's no proper, understanding of what it does, how it does it, because the documentation is not there. The motivations could be things like time pressures as well, for example. Sloth sometimes, perhaps. But at the end of the day, an API that doesn't have documentation is like not having an API, right? I call it the ABC of a good API, right? An absent API doc means like not having an API. Back documentation, you're going to get a lot of pissed off developers as well, because then they'll have to try things a few times, and they're going to come back to you and say, this doesn't work, your steps don't work, what do I do now? And can find it. Sometimes you may have the right documentation in place. Your API might be actually properly designed and easy to use, and the experience is great, but then you cannot find it. No one knows that the thing exists. So there's something called developer portals, which I'm sure you've heard of, but not many organizations have it, actually. Don't know why. Maybe it's complexities of large organizations, perhaps. But, doesn't have to be rocket science. It could just simply be a web page, right? Or there are API catalog tools, API management tools do come with API catalogs. And the idea being is make it easier for people to find an API that you've spent time building. Because otherwise, someone is going to come, is not going to find it, and the wheel is going to be reinvented. And obviously, that's not a good thing, I feel. This is kind of like an example of what I think, at least a good API should look like. So you should have stuff like, an introduction. What is the API for? How do you deal with authentication? That tends to be it could be sometimes a bit complicated, right? Especially in finance industry. when you're dealing with things like obscure JOTs, and it can get a bit. It can be a bit complicated. So do document your authentication procedures properly, right? How to obtain a token and all that. How you handle errors, any constraints on the API. If you're doing public APIs, then I would extend this and say also talk about your monetization models, right? How do you charge for the API, or if it is free, what the restrictions are. A log, so you talk about the versions, but most importantly, you want to describe your resources, all the resources that you've got, and you want to provide some sort of playground, right? If you're going through the API documentation, right, why not provide a facility to also try it out, right? So the developer trying to consume this API can get more familiarized with it. Some tools go beyond just that and can help you auto-generate client code or server code if you're following an API design first, which means not only you're getting familiarized with your API documentation, but you could scaffold your Spring Boot application or your Node.js application or your Python or whatever language you're using. I mentioned 2 tools, APIary. I also mentioned Swagger Hop. There are more. Do check them out. They are very useful. And this is the example with APIary that I was talking about. It's almost a copy of what I was talking about. You have all these capabilities. Again, I'm a bit biased towards Oracle, but there are many other tools out there, right? So you just want to make that clear. Some APIs that I quite like, just sharing some examples, the Stripe and Strava APIs, I think they are very good API documents. Check them out. I think you can learn from those examples. Yeah, I'll let you take the pictures. I'll tweet these slides as well. My Twitter is small in there, LouisW19. And this is my absolute favorite one. Jealousy. Right. Come on. The guy is obviously looking at the shoes. Come on. I mean, it's quite obvious, isn't it? Who in the audience have heard of GraphQL? Wow. Who in the audience have implemented GraphQL? Like a lot less. Who in the audience have used GraphQL? Like same as implementation. Right. So I'm going to do a demo then. And I have a bit of time. So GraphQL you'll see it firsthand when I do my demo. It really is a good technology for certain use cases. I don't like this discussion of, REST is better than GraphQL or GraphQL is better than REST. Tools are there for a reason. Some tools are better than other tools for certain things, right? I think GraphQL for usability and UI-driven APIs is absolutely brilliant. And I'll show you why in a second. More than that I think that's the reason why the popularity is increasing. I've done these similar sessions like these. I've done like 8 of them around the world, actually, in San Francisco, in India, and in the UK, I think as well. Anyways, the bottom line is, the trend is like every time I update this slide, I update the link, I regenerate the Google trend, and it just continues to go up. The adoption is really kicking. It's growing like crazy, and there's a reason for that. So if you're not familiar with GraphQL, actually you all are. So the idea is that you define an object type, a schema, you define what data you want back, and then you get exactly what you want. So let me just go to the demo, right? This is a very simple demo. It's in my GraphQL samples GitHub repo. You can get it from there, and you can try it out. A word of warning, there's a library I need to update, so I have a security warning, 4 security warnings, actually, so I need to go and update that. It's an outdated library. But I'm not going to fix that now, not live, at least. So I'm just going to do a very quick demo. So what I'm going to do is I'm just going to kind of query a GraphQL service that's going to give me a bunch of countries based on different conditions. But the code is actually not persisting a database or anything like that. I'm aggregating data from different sources. In this case, I'm aggregating data from a REST API, actually called REST countries. And I'm obtaining I actually created a Google web scribe that is kind of like conducting a Google search. But then I'm using a library called Cheerio to introspect the HTML response and obtain the result of the currency conversion. So from a consumer perspective, you don't even know that I'm doing that, right? So it's just to illustrate an example on how GraphQL could be adopted, right? So let me just go to the code. Yeah, so that's my repo. You can see later. It's in the slides as well. So I've already downloaded my code. It's here. It's the example 4 I'm going to show right now. So it's tutorials, right? It's from nothing to a bit more advanced. And then example 5 includes UI, how to consume GraphQL, right? So I'm just going to start the thing. I'm using Node. Sorry if you hate Node, but the reason I'm using Node, I'll explain it, is there is a company called Apollo, and these guys have really done a lot of good work building tools for GraphQL. Very mature framework and server for GraphQL. That's why I like it. But there is, dependencies in Spring Boot, for example, as well, or other frameworks in Java, so you can use Java easily, no issues. It's more than, a lot of people use it in Java as well. So I'm just gonna I just started my server. So I just go to my Graphical. Graphical is an IDE for GraphQL. You might have heard of it. So imagine I don't know anything about this API. I don't even know what it does. So start introspecting my GraphQL. Can you see it? Let me just zoom it up a little bit more. So let's say I want to do a query. So queries is a query. Mutation is like the equivalent of post, put, and patch in HTTP. And subscription is actually a webhook. But the beauty of this is part of the specification itself. So GraphQL, by design, supports webhooks. In REST, it's kind of like, you could define your own implementation of a webhook in a REST, although it's kind of standardized informally, but yeah. So I'm just going to do a query, right? In this query, okay, there's an operation called getCountries. You can already see how similar it is to RPC-style APIs. So I'm going to get the ID, the name, and the code of the country. Yeah. So if I make this call, I should get 255 countries. Yeah, 250, sorry. So that was a REST call to the Backend API I mentioned, right? But let's say I want to constrain this. Let's see if I have any filters in this API. Well, I can filter by name. So let's get all the countries that are great. Only one. Right. So let's do 2 queries then, right? Because you can do this in REST quite easily. In fact, if you look at my implementation, when I did the complete search, I just did all in the way they implemented the public REST API. But then when I did the filter, it just constructed this URL, right? So I could just call it. I'm using a plugin to visualize better JSON responses in Chrome. So I can just do this in REST, right? Just type in that URL. Now the issue is, what if I want to have another query, right? And this time I want all the countries that have sort of the word United. But this time, I also want a completely different set of data, right? Response. I want to get the currency. I want the name of the currency. I want the code. I want the X-rate 2 and the X-rate, yeah. And I do have another filter, which is I want to convert. And let's convert to pounds, yeah? So if I make this call, what happened is, the implementation of my GraphQL server already understands, okay, you have 2 different queries within the same payload. I'm just going to execute 2 queries. And they're completely different, but they're part of the same payload. So I'm just aggregating the different calls, right? It parallelizes the callbacks, right? And then just join backs and send their response. So you can see that in my server. So all the different calls happen, right? The way Node works is asynchronous non-blocking, right? So everything was happening in parallel. And then you got the conversions. This is from the result of Google. In fact, you can see the Google, what I'm doing when I make the Google call. It's exactly this. 1 second. I'm doing this, but then I inject the header, so Google thinks I'm Chrome, right? So I get exactly this response, and then all I did is I inspected the code, and then I just found, the name of this particular section within the HTML. I extracted that, and that's what I'm presenting back in my GraphQL. But that's just an example. It could be anything. It could be a database. It could be another API. It could be gRPC protocol buffers, or it could be even RMI, IOP if you are still implementing EJVs. Doesn't matter. So I've done that, right? So you're getting to see the idea. So let's say now I want to convert all the countries. Sorry, I forgot to say. If I was to do this in REST, let's say I want to do another query, a third one. Yeah. let's prettify this because it's getting a bit complicated, yeah. And then I just want to put a Ven. I'm from Venezuela, by the way. So don't ask me about Maduro, please. I had to say it. Anyways, now I have 3 queries, yeah. And you know, it could be completely separate queries. If you were to do this in the REST paradigm, either the UI has to make 3 different calls, right? Or you have to implement an aggregate REST API, which in the way the REST architectural style works, is not natural to model resources in that way. What are you going to call that resource? Aggregate countries? Is it really a resource? So that's where I kind of feel like, you know, this is probably a better option for this type of use cases, right? So I hope you got the idea. So let me do one last demo, which is cool, which is let's convert all the countries in the world, the currencies of all the countries in the world to pounds, yeah? So this is going to take a while, and my machine might break, because if you see the server, it's going to start fetching. So the first thing it's doing is fetching all the countries, and then it should be working, but maybe I broke it. Well, I'll give it 5 more seconds. If not, I continue to my presentation and then come back to see if something is happening. Anyway, what should happen is it's going to call give me all the countries, and then it's actually going to start converting by making subsequent Google calls. So let me, maybe I did something wrong here. Let me just stop my server and start again. I'm going to try one more time. If not, I'm going to move on because I don't have that much time left. Right, so let me just put the currency. Maybe it's that. I didn't put it. I can just, yeah. Okay, so I'm going to go back to my presentation. I'm going to let that go in, yeah? And then we'll see if it worked or not. I can just switch my screen. Let's see. Yeah. Right. So we talked about envy. Pride. Who is that guy? I mean, I think it's a great example, right, of pride, you know? There was this video where they were counting how many times this guy said, I know better than him, or I'm better than him, or better than you, or better than, it was like 100 times in like, I don't know how many interviews or whatever videos. Anyways, you get the point, yeah? Pride. I call it the bottom-up API design. I mean, the picture is not really representative of bottom-up API design, but I just like the fact that it's like, you have to like, you know, yeah, you get the point. But the idea of it is that you are a backend system developer. You know your model more than absolutely anyone because you built it, right? Because you've been architecting that for a while. You have all that domain knowledge. And because of that, when you construct the API, you construct it from your point of view based on what you think is best. And it might be a very good design from your point of view, but there may be, and this is related again to my first deadly sin, you forget about the usability of that API. You forget that maybe it's not the best way to build that API. And I see this a lot, for example, when you auto-generate Swagger from Spring Boot, for example. So you go and write your code first, right? Because, as I said, you have the domain knowledge in your head, so it's quicker for you to actually just go and write it. But then you generate Swagger from your code, and then when people try and use this API, it's not helpful. I saw this issue in practice. There was an API we were building in Brazil for an agricultural company. So what happened is the guys from the UI side, they were building a UI in React, running in Lambda for the server. Anyways, they had to kind of like build a wrapper API because it was almost like calling tables. It was horrible, and it's not good. Maybe it's good if as a controller, but then you should put something on top so it's more usable. And I guess my point is, there's no better accomplishment as a designer to build an API that is fit for purpose, an API that people can use. I mean, that is not helpful, right? I mean, that design, I think, I wouldn't go to that toilet at least. It's not here, by the way. You don't have to worry about the toilet here. Anyway, the point is design your API first for usability. Actually, I did this rather quick, and I have a fair amount of time for a Q&A. So let's go to Q&A. Any questions? There's a lot of people in the room, so I'm sure you have questions. Anyone? I like the Spring Boot dependency for GraphQL. If you go to if you're using Visual Studio Code, for example, you can use if you're using Spring 5, you can just type GraphQL and you can find it. That's at least from my experience. Another question? Yep.
You talked about before about one of the sins was to take like a whistle or a soap service and then
Convert
it with the actions. I've seen that a lot. What do you say to someone who builds something like that? How do you convince them to take another approach?
So the question was, he's also seen a lot people that convert from Whistle to REST. And what would I say to people that are doing this to convince them not to do it? It's a very, very good question, and I'm having this issue as we speak as well. So what I'm trying to do, and I'll tell you what I'm doing in my work for you, is I'm creating a point of view to explain why the REST paradigm and the RPC paradigm are not really that aligned. And when you do that conversion, you're not really gaining anything. What you're really doing is adding more technical debt, right? You're just extending the problem, right? You're not really adding value. And that's kind of my approach to this. I really don't see the benefit. That would be my suggestion. Yep. Sorry, I think he was so. Yep.
Do you know of any API gateways that provide GraphQL probability so that they handle the connection of all these resources?
Excellent question. The question was, do I know of any API gateway that supports GraphQL natively? The answer is, I don't think there is yet. I was researching a lot. I'm pushing internally in Oracle, for example. I'm pushing like, guys, you need to add this stuff. Not just. By the way, you can use an API gateway with GraphQL because GraphQL is a HTTP endpoint anyway. It's a /GraphQL. So if you could use the API gateway, for example, for Auth 2.0. The problem is the gateway will not understand the operations or the queries that you're conducting. So when you have to be more fine-grained as to how do you enforce this scope to allow you to do this operation, you have to write custom stuff. And that is where the problem lies with REST-oriented API gateways. What I'm doing is, I'm implementing a GraphQL as an API gateway. So sometimes I do put the API gateway on top to sort out maybe Auth 2.0, but then I just use my GraphQL server, right, as a gateway, pretty much, right? And I have to write the code, right, to deal with things like authorization. If you Google a GraphQL gateway or GraphQL API gateway, you see that is something that is evolving as a pattern. Very good question. You had a question as well?
Do you see GraphQL in some ways going back to RPC?
Do I see GraphQL going back to RPC? Well, I think GraphQL is an RPC-based API, period. But made very, very easy. For example, who's familiar with gRPC? Okay, not that many. So gRPC is a protocol, RPC-based protocol created by Google. It's extremely efficient, right? It's, if you're dealing with huge amount of data, it can be quite beneficial. And most importantly, it supports bidirectional communication, right? So natively, right? It doesn't matter which way you're talking. But back to your question, for me, it is RPC-oriented. It's just simple. And that's why I like it. And I do think that it's easier to convert. Back to your question, it's easier to convert from Whistle to GraphQL than it will be to convert from Whistle to REST. And the reason being the paradigms are more aligned. You see what I mean? The intents are also modeled as operations. So if you're converting, GraphQL is probably a better option. And that's also one of my arguments. I just remembered. Another question? Yes?
What are the main bottlenecks of GraphQL? Because I've heard of caching and this kind of things. So you end up maintaining REST and Graph side by side, and then it ends up that you can't do everything that you can do in REST in GraphQL. You know what I mean?
I think your question is, are we reinventing the wheel with GraphQL? Is that kind of what you're saying? Things like caching or?
No, but my question is more like we have some problems that we already sorted a long time ago with REST, like caching.
Yeah.
sort of
Yeah.
thing. So how do you see where we are with GraphQL at this point?
Yeah, so the question was, they've already invested a lot of time and effort solving problems in REST, right? How do I see GraphQL solving these problems, right? And like caching. So the short answer is, nothing is a silver bullet. Maybe GraphQL doesn't make sense if you already made a huge investment with REST, right? You need to really think about, does it make sense for us? You can always put GraphQL on top as well, right? As it means to solve some use cases, make it easier to leverage those REST APIs. That's another way to introduce REST. But the answer to your question is libraries are evolving very, very fast. For example, the Apollo client library supports client-based caching already out of the box. And there are more client-based libraries. If you go to the GraphQL website, you'll see that there are a bunch of client-based libraries, right, that already support client-based caching, so you don't have to build it from scratch. So that's the answer. Yeah. About API design, what do I think about SOA principles in the world of microservices? I mean, microservices is SOA, isn't it? I mean, in fact, Martin Fowler said microservices is a subset of the service-oriented architecture paradigm, and I agree with that. I think the main difference is, I think when we did, by the way, I didn't show it, but I wrote a book on SOA governance a few years back. It was 400 pages long, and then I realized it's a bit too complicated, perhaps, right? We perhaps took the paradigm to the extreme, right? And we were perhaps too strict as to how you implement SOA. So I think what's going on with microservices is that, in my view, it's simplified. It's been simplified, and the way you realize and implement your services based on principles like the single responsibility principle, or bounded context following domain-driven design, or all these good patterns that are emerging are really bringing to life and showing the benefits of SOA, which I don't think we were able to achieve in the old SOA world. So I think many of the principles apply, but I wouldn't just, I think the paradigm evolved, right? And I think we should, also, pick what worked and don't use what didn't work. If you come from that world, I come from that world, so that's what I did. I think, yeah, they were very good questions. Thank you very much.